Welcome to the video on balancing chemical equations. This equation on the left is quite a simple one with one of our group 1 metals, and it is lithium reacting in oxygen to produce the metal oxide, lithium oxide. So this is the reaction that happens when you burn lithium. As you can see, we've got lithium, we've got one atom of lithium. You can tell there's one atom because there is no number associated with the lithium. We have got two atoms of oxygen, and you can tell that because of the little 2 next to the O. And here we've got lithium oxide. So two elements present in total, lithium on its own, oxygen on its own, and then when they have reacted together, they are put together to represent that lithium and oxygen are now in a compound together, lithium oxide. So this is a chemical equation, much like the equations that you will have seen in maths with addition, but instead of an equal sign, we have got an arrow, which means reacts to give. That's what the arrow means. Okay, so that's great first of all, that's a chemical equation, but that is an unbalanced chemical equation. And I'll show you what I mean. What I mean by unbalanced is that there are not equal amounts of each element on the left and the right of the arrow. The way that I look at this, and you'll probably see it immediately, but we will do more difficult ones, so it's worth learning the process first of all. What we'll do is we'll write down each of the elements that are present in the entire equation. So these are the only two in the equation at the moment, and I'm going to put a number on the left and on the right to represent how many atoms of each element are present. So on the left of the arrow we've got one lithium, and on the right of the arrow we've also got one lithium. Excellent. Now onto oxygen. On the left of the arrow we've got two oxygens, and on the right, because there's no number associated, we've only got one. Okay, so this is not a balanced equation. A balanced equation, like I said, is something where there is an equal amounts of each element on the left and on the right. And the things on the left of the equation are known as the reactants. They react together, and the things on the right of the arrow are called the products, the things that are produced. So we have to find a way to try and balance this equation. Now is the best time to think about a couple of rules. Okay, so you cannot interfere with the small numbers. So you don't mess with the little numbers, or the numbers in subscript. That's what it means when the numbers are underneath the element. You don't mess with the little numbers, okay? Now, the little numbers, what they tell you is they tell you how many atoms are in each molecule. A molecule is a group of atoms bonded together, the smallest unit of a compound that can take part in a reaction. So, in this lithium atom here, there's just one lithium. So maybe I would draw it just like that, a little particle of lithium. Okay, I'll colour it in as well, why not? And then over here with our oxygen, we've got a little 2 next to it. That demonstrates that in the oxygen molecule, there's actually 2 oxygens there. Similarly, when they react together, we've got a lithium and an oxygen. Okay, so when we're trying to get these to balance, and as you'll see, the lithium is already balanced, there is equal amounts of lithium on the left and on the right, so we don't really want to mess with that. But on the oxygen front, we've got 2 oxygens on the left and 1 on the right. That is not equal amounts. So we're going to try and fix that with some really simple multiplication. we can't just go messing. We can't just take away that 2 and make it 1, because oxygen in the air exists as a 2-atom molecule. It exists as a diatomic molecule. So we can't mess with anything there. In fact, what we're going to have to do, is we're going to have to pop numbers in these positions here. Okay, so we don't mess with the little numbers, but we can add big numbers, and by big I just mean that they will be the same size as the capital letter of the element. We can add big numbers in front of the elements and compounds. Okay, and the effect that putting big numbers in front of here will be to not change the number of atoms in a molecule, but the effect will be to give us more molecules. Okay, so for example, over here we want 2 oxygens to balance with the 2 oxygens on the left. Well, the only place on the right of the equation I can go is this little space here. So I'm going to pop a 2 in there, number 2. And the effect that that has is as follows. It is 2 times that oxygen. Okay, so I've now got 2 of those. Excellent. Now we are balanced between the 2 O's on the left and the 2 O's on the right. However, what you will notice is that because I can only put big numbers in front of the elements and compounds and not in between the elements of a compound, I've also doubled the amount of lithium that I've got. So I'm going to have to put a 2 here as well, so that I now have 2 lithium as well as 2 oxygen. So I've given myself another headache, but let's consider that in a moment. Let's have a look what happened to this little particle diagram I have. I've put 2 LiO. So what does that mean? Well, it essentially means I've got 2 of these molecules now, and the way I would draw that is by having 2 of these molecules. So that's what I've done in a pictorial sense. I've got 2 lithium oxides, and there's 1 molecule of lithium oxide, and there's the second one. Okay, so I'm going to still have to balance. We've now balanced our oxygen, 2 and 2, but we've got an extra lithium. So I'm going to have to look over to the left side of the equation. There's 2 places I could put a number. The oxygens are already balanced, so I think I'll put a number in front of the lithium. I'll put a number 2, and again 2 times 1 equals 2. Now I've got a balanced equation. I've got 2 groups of lithium atoms. They're not joined because they are not part of a molecule. They're 2 separate lithium atoms, plus a single oxygen atom, a single oxygen molecule made of 2 atoms. And they react together to give me 2 molecules of lithium oxide. And that's all it is, really. Okay, so the thing I can't stress enough here is don't be afraid of trial and error. Trial and error. And what I mean by that is that you may well end up putting a 2 in the wrong place or a 3 in the wrong place, depending on what the equation is. Okay, if you start doing this method and then you get to the point where you think the numbers just aren't going to balance and that they're just getting away from you, then you may well have put in the wrong thing somewhere and you'll have to start again. So use a rubber, that's fine. Okay, use separate colours, use a rubber, otherwise you will forget which parts you've added and which parts were originally in the equation. I've done plenty of these, and sometimes you just it gets away from you and you need to start again because you've put a number in the wrong place. At the start you really are just feeling around for a correct answer. Let's pop in another one. And what I want you to do is pause the video when you've written this in and have a go, and then resume it and I will do it along with you. Okay, so in this one we've got xenon. One atom of xenon reacted with 2 atoms of fluorine, one molecule of fluorine with 2 atoms in it, and together that reacts to give us xenon fluoride. Okay, so look at my rules and then write out the elements as they appear. Xenon, fluorine. Pop in the left and right of how many atoms of each element there are, and then try and balance the equation. Okay, with only putting numbers in front of the elements and compounds. Pause the video now and have a go, and then return to me in a second. Okay, so on the left we have 1 xenon, and on the right we have 1 xenon. On the left we've got 2 fluorine, and on the right we have got 6 fluorine. Okay, the xenon is already balanced, so for now I'm not going to touch those. Okay, on the left I've got 2 fluorine, but on the right I've got 6. So this is actually quite a simple one really. We've got our big number 3 in there, so that now I've got 3 groups of this element. Now I've got 1 molecule of fluorine, 2 molecules of fluorine, and 3 molecules of fluorine. Remember that the lower number means how many atoms are in a molecule, and the big number tells me how many molecules there are. Okay? So we're going to times that by 3. That equals 6. That's all we need to do. That's it all completely balanced. Okay? Let's have a look at some more. Okay, so let's have a little go at this one here. You've got Ag, which is silver. You've got hydrogen sulfide, and that reacts together to give silver sulfide and hydrogen gas. Okay, pause the video here, and then just as before, write out your elements and the numbers of atoms either side. Pause the video now. Okay, welcome back. So we have got Ag, which is silver, we have got sulfur, and we have got hydrogen as well. Okay. On the left we've got 1 silver, and on the right we've got 2 silver. On the left we've got 1 sulfur, and on the right we've got 1 sulfur as well. On the left we've got 2 hydrogen, and on the right we've got 2 hydrogen. Okay, so hydrogen's balance, sulfur's balance, only the silver doesn't, so very simply we are going to pop in 2 silver. So 2 of those, now we're perfectly balanced. Excellent. Okay, let us have a little go at this one over here. Sodium plus chlorine gives me sodium chloride. Okay, same as before. Let's pause the video and pop your elements in its table. Welcome back. We have got sodium and chlorine on the left, and on the right we have got 1 sodium, 1 on the right. We have got 2 chlorines on the left and only 1 on the right. So we're going to have to balance these chlorines somehow. We need to increase the numbers on the right. Well, there's only one place that I can go on the right. So we're going to put 2 sodium chloride. So I'll have to times this by 2. Now the chlorines are balanced. However, we've also doubled the number of sodiums, and it now doesn't balance with the left. So we'll look to the left. Okay, I can just times that by 2. Excellent, equals 2. And now we are balanced. Okay. Let us look at this one here. Iron oxide and carbon react to give iron and carbon dioxide. Pause the video now and have a go. Welcome back. We have got iron, we've got oxygen, we've got carbon. On the left we've got one iron, and on the right we've got one iron. On the left we've got one oxygen, and on the right we've got two oxygens. On the left we've got one carbon, and on the right we've got one carbon. So, I'm going to need to deal with this unbalanced oxygen first, aren't I? So, I'm going to put times 2, so that we've got 2 oxygens. But I've also had an effect on the iron as well, so I'm going to have to times that by 2, which unbalances them here. Now I'm going to have to pop a little 2 on there, and what we have is 2 ions, and now everything balances. Okay, hopefully you got those right, and if not, hopefully you can see where you went wrong. Now, this one over here is a little bit of a stinker, really, isn't it? There's lots of extra things going on here. Let's have a look at how you would tackle this one. Okay, and this one over here, let's see, we have got potassium, we've got oxygen, we've got hydrogen, and we've got carbon as well. So that's the most we've had so far, 4 different elements in the same equation. Okay, the potassium, there's one of those, and the potassium over here, there's 2 of these. Okay, what I want you to draw your attention to now is the fact that when we're looking at oxygen, all of the compounds here, all of 4 compounds actually have oxygen in them. So we're not just looking at oxygen in one of these compounds on either side, we're having to think about the fact that there are different compounds to think about. So the oxygen on the left that we'll have to look at is we've got 1 over here, but we've also got 2 over there. So we've got 1 plus 2, which of course is 3. And over here, we've got 3 plus 1. We've got 3 oxygen there. And we've got 1 oxygen over here. And that gives us a total of 4. Okay, hydrogen's a little bit more easy, where we've got 1 hydrogen on the left, and we've got 2 hydrogens on the right. Similar with carbon, we've got 1 on the left and 1 on the right. Okay, so we have a total of 3 elements which are not balanced. Potassium is not balanced, oxygen is not balanced, and hydrogen is not balanced. So if at all possible, I would like to avoid touching either of these spaces, because that's going to have an influence on the carbons that are associated with them, isn't there? So I'd like to try and avoid that. Okay. So what am I going to do? Well, I always like to start with a 2, just to have a go. The very first one, we could put a 2 there, and again, remember it's trial and error, so this might not work out, but let's see. What effect does that have? Well, it has an effect on these 3 elements. So times the potassium by 2, and it's going to become 2. Okay, they're balanced, so that's not bad at all. It has an effect on the oxygen, okay? It has an effect on this 1 oxygen, the one that's over here. It doesn't affect these 2, does it? Because these 2 are associated with a carbon over here. It affects just this 1 oxygen here. So I'm going to times this one by 2. So now there are 2 there. The 2 plus the other 2 gives me 4. So yes, I have balanced them. Excellent. This big 2 also has effect on this hydrogen, and that times it by 2 as well. Okay, so now we have a balanced chemical equation. Alright, here's one that I'd like you to do yourselves in the same way that I've done previously. You've got the elements carbon, hydrogen and oxygen all appearing in this equation. I would like to direct your attention to the fact that the oxygens are in two separate compounds over here. So what I suggest you do is that just like I have split the oxygens into separate entities here, I suggest you do the same over here to help you when you start timesing them. Okay, pause here and then have a go. Okay, welcome back. Let's have a little look then. So, we've got 3 carbons, we have got 8 hydrogens, and we have got 2 oxygens. We have got 1 carbon, we have got 2 oxygens, plus another one, and we've got 2 hydrogens. Okay, so not a single thing here balances. Isn't that fun? So, what are we going to do? I wonder if you got to an answer, or if you got a bit frustrated. So, immediately when I look at it, I think, what can I do? Well, if I try to get this 1 to become a 3, I could put a 3 in front of this C. That's an opportunity. That would have the effect of giving me 6 O's here though. I could put a 4 in front of this H2O here, and that would give me 8 H's, but it would also add another 4 O's onto it as well. Okay. I think what I'll do is I'll go for 3 C's and see what effect that has. Don't know at the moment, but that's okay because I can always start again if it's an issue. So times by 3, we knew that was going to be okay, so that's fine for now. Over here we've got our 2 oxygens and we're timesing that by 3, so 2 times 3 equals 6, and we've got another 1, so at the moment we've got 7 oxygens. Not sure how happy I am with 7 oxygens if we're going to be able to take that to balance. But hey ho, let's keep on going for now. What else do we need to balance? Well, I spoke about that H2O before, so why don't we try that anyway? We'll go for the 4H2O, and then that gives us the 8 at least. So 8 of that also has an effect on the O's. It has an effect on the 4 O's here. Ah, okay. So now actually I'm getting rid of this odd number by timesing this 1 oxygen by 4, which gives me a total of 4. And I've not got 7 anymore, that means I've got a total of 10. Now that's a big number, but at least it's an even number, so I can work my way up to it, and because I've got this oxygen on its own, I can put any number here and make all the even numbers. So all I've got to do here is times it by 5. Okay, and that'll give me 10, and I've got a balanced equation. Excellent. Okay, what I would like you to do now is go ahead with the questions that I have set and try your best. Okay, best of luck, folks. All right.